Before we understand blockchain, that we first need to understand one simple thing, a network. A network is just a group of computers connected together so they can share information and communicate with each other. The internet itself is a network. Your phone, laptop, servers, and apps are constantly connected through networks every second. Now imagine thousands of computers around the world, all connected together, all sharing the same information at the same time. That's where blockchain begins. Blockchain is a digital system that stores information in blocks. Every block contains data, and once a block is full, it connects to the previous one, forming a chain. That's why it's called blockchain. Blocks connected in a chain, but here's what makes it powerful. Instead of one company or one server controlling everything, thousands of computers in the network verify and store the same data together. This makes the system decentralized, transparent, and extremely difficult to change or hack. Once information is added to the blockchain, it becomes permanent and secure. Okay, so the guy in the image is Hans Peter Luhn. Back in the 1950s, he was already working on ways for computers to organize and verify information automatically. And even though blockchain didn't exist back then, ideas from pioneers like him helped build the foundation for modern data security systems. Later on, computer scientist Rivest developed hashing algorithms like MD5, which became a huge step forward in modern cryptography. Then came Ralph Merkle, who introduced something called Merkle trees. It allowed massive amounts of data to be verified quickly and securely using hashes instead of checking everything one by one, and this became super important for blockchain technology later on. Then in the 2000s, the National Security Agency developed SHA-256, a much more powerful hashing algorithm, and that's the exact hashing system used in Bitcoin today. So what exactly is hashing? A hashing algorithm basically takes any information, text, files, transactions, literally anything, and converts it into a unique digital fingerprint called a hash. And the crazy part is, even changing a single letter completely changes the hash output, which means if someone tries to tamper with the data, the system notices instantly, and that's one of the core reasons blockchain is so secure. So in here, a block is a collection of verified transactions. Every time a transaction takes place on the network, it is recorded and grouped with other transactions inside a block. But a block contains more than just transaction data. It also contains a timestamp, its own unique hash, and the hash of the previous block. Once a block is verified, it becomes a permanent part of the blockchain, and a new block begins collecting the next set of transactions. Now that we know what a transaction is, what a block is, and how hashing works, let's see how all of these pieces come together to create a blockchain. Take a look at this image. On the far left, we have block 1, also called the Genesis block. This is the very first block in every blockchain. Since it's the first one, it doesn't have a previous block to refer to, so it's the starting point of the entire chain. Inside the block, you can see transaction data, and after all that data is processed through a hashing algorithm, it generates a unique fingerprint called the block hash. In this example, it's shown as 6F2A.8C3D. Now here's where blockchain gets interesting. Move to block 2. Notice the label at the top saying previous hash 6F2A8C3D. That isn't block 2's own hash. It's actually storing the hash of block 1. Think of it like this. Every new block carries the digital fingerprint of the block before it. That's what creates the chain in blockchain. After block 2 stores block 1's hash, it also contains its own transactions. Those transactions are hashed, creating block 2's own unique hash, shown here as 3B7E.91AF. Then block 3 does exactly the same thing. It stores the previous hash from block 2, adds new transactions, calculates its own hash, and passes that hash to the next block. The process repeats over and over. Every block is connected to the one before it through cryptographic hashes. Now imagine someone tries to change a transaction inside block 2. Remember what we learned about hashing. A tiny change in the data creates a completely different hash. So if block 2's hash changes, block 3 is still pointing to the old hash. The link breaks. Then block 4 is pointing to block 3's old hash, so that breaks too. In other words, changing one block would require recalculating the hashes of every block after it. On a decentralized blockchain where thousands of computers already have the original version, that's practically impossible. And that's exactly why blockchains are considered immutable. Once a block is added and accepted by the network, it can't be secretly modified without everyone noticing. So in one sentence, transactions are grouped into blocks. Each block creates its own hash, and every new block stores the previous block's hash, forming a secure, tamper-resistant chain of blocks known as the blockchain.